Hello everyone, welcome back to my channel, and today our topic of discussion is expansionary fiscal policy, ISLM framework. So actually it is one type of aggregate demand management policies. So the main objective of expansionary fiscal policy is to boost up the aggregate demand. Now, how will it work? So before understanding how will it work, we can start with what are the instruments of fiscal policy. So either the government can increase the public expenditure. So as public expenditure is a component of aggregate demand, whenever public expenditure increases, it will automatically boost up the aggregate demand. The other thing is that if the government reduces the tax, so if the tax is reduced, the disposable income in the hand of the people will increase. So the consumption will increase, and consumption is a part of aggregate demand. So again, we'll find an increase in aggregate demand. So now we'll start with an ISLM model. So first, let us discuss it intuitively, then we'll prove it graphically, and finally we'll go to the mathematical part of it. So first, let us start with if we start from a situation whenever there is simultaneous equilibrium in the commodity and money market, which is represented by the intersection of IS and LM curves. So we show here in horizontal axis represents aggregate demand, vertical axis represents rate of interest. So this is a standard IS curve which represents the inverse relationship between rate of interest and aggregate demand that maintains commodity market equilibrium. And this is the LM curve. This is the LM curve that represents the direct relationship between aggregate demand and rate of interest that maintain the money market equilibrium. So this is the point where we find is the point of simultaneous equilibrium. So OY0 is we start from a situation when OY0 is the aggregate demand and OR0 is the rate of interest. So now if we start from a situation if either government policy, either there is an increase in public expenditure or there is a decline in tax. So here graphically it will be same, mathematically it will be different. So what we see here, ultimate G increases or tax declines, whatever it is, ultimately the aggregate demand will increase. So first start it initially what we will find, aggregate demand will increase. Now what will be its effect in the asset market? Definitely increase in aggregate demand will cause an increase in demand for money. So here what we see, money demand will increase. So money market or the asset market was in equilibrium. Money demand equals to money supply. Now suddenly there is an increase in money demand. So what will happen? What will be the consequence? Consequence will be an aggregate demand situation will be created in the money market. So we call it the excess demand for money. So as there is excess demand for money, there will be definitely excess supply of bonds in the bond market. As we know that the money market and bond market are interrelated. So whenever there is excess supply of bond, the bond price will rise and the rate of interest will fall. So, it will be the reverse, the bond price will fall and rate of interest will rise. So, excess demand for money will cause an increase in the rate of interest. So, it will have two different effects. First, so whenever the rate of interest rises, we know that the demand for idle cash or the speculative demand for money is inversely related to the rate of interest. So whenever rate of interest rises, the demand for money will decline. This is one effect in the money market. And rate of interest rise will also have its effect in the commodity market. What is that? So first what we see here, money demand will fall because of rise in rate of interest. And second thing, as rate of interest rises, we will find that it will choke off the private investment. So investment will decline. So this effect is known as the famous crowding out effect. So the public investment here crowds out the private investment. So if the investment rises, again there will be a decline in aggregate demand, and consequently the demand for money will decline. So this entire process is continued unless the equilibrium in the money market is restored. So if we show it graphically, whenever there is increase in aggregate demand, the IS curve will shift rightward. So what we see here, initially aggregate demand rises from Y0 to Y star, and this is simply because of the increase in increase in public expenditure. But what we see here, this point is on the IS curve, but it is below the LM curve. So below the LM curve means the rate of there is excess demand for money. So rate of interest will start to rise, private investment will decline, and finally what we see, the next equilibrium point is E1, when aggregate demand is Y1 and rate of interest is R1. So what we see, because of the rise in rate of interest from R0 to R1, aggregate demand is falling. And what is the reason behind this fall? The decline in private investment. So this is basically the crowding out effect. So now we can show the value of the public expenditure multiplier. And we will show the case of tax multiplier. In other video, I will explain the balanced budget multiplier. So first let's write the commodity market equilibrium condition. Y equals to A plus B into Y minus T. So Y minus Y stands for the aggregate demand or income, and T stands for the tax. So this is the disposable income. The consumption is a function of disposable income, plus private investment will given as I bar minus H into R. This is I bar is the autonomous investment and HR is the part of investment that is influenced by the rate of interest. And we know that there is an inverse relationship between rate of interest and private investment. So plus G. So this is our equation 1, commodity market equilibrium condition. And what are the properties? A is autonomous consumption, which is greater than 0. B is the marginal propensity to consume. So its property is, its value will lie strictly in between 0 and 1. And H is greater than 0. So this is the commodity market equilibrium condition. Now we write the money market equilibrium condition or the asset market equilibrium condition. So M bar is the money supply, which is exogenous or autonomous, because this is the discretion of the central bank how much money to inject in the economy. So M bar, and this P is the price level, we call it the real balance here, M bar by P, or real money supply, so which will be exactly equal to money demand. And we know that demand for money has two parts. One is the transaction demand for money plus speculative demand for money, which depends upon the the aggregate demand, which we normally get from the quantity theory of money. But what is the Keynes? The addition of Keynes is the speculative demand for money. So L is greater than 0. So what we see here, if aggregate demand rises, the demand for money will increase, but if rate of interest rises, demand for money will fall. So this is our money market equilibrium condition. Now what we'll do, differentiate both equations 1 and 2. So I am using here Cramer's rule. You can use here also the normal substitution method. So I use Cramer's rule because it takes less time to solve the equation and it is easy. But if you wish, you can use the substitution method, the result will come same. So if we differentiate the IS equation, what will get? dy b dy minus h dr plus dg. So we can write or in other words 1 minus b equation 1a. And if we differentiate the money market equilibrium condition, what will get? K dy minus L dr equals to 0. This is 2a. So what can we do here? The set of equation can be represented into a matrix multiplication form. So we can write here, the coefficient matrix will be this will be the coefficient matrix. So this is in the set of equation is represented in a matrix multiplication form. So now, whether Cramer's rule can be applied or not, we have to check the value of the coefficient matrix should be non-zero. So if we say delta equals so if delta is non-zero, we can apply Cramer's rule to solve the value of dy and dr. So here it is equals to minus L into 1 minus b minus h into k equals to minus so L is positive, B is marginal propensity to consume, that means 1 minus B is marginal propensity to save. It is positive, HK positive, so the value will be negative. So that means it is non-zero. We can use Cramer's rule here. So by Cramer's rule, we can write dg equals to 1 divided by delta. Sorry, this is dy. We are solving the value of y. Dy equals to 1 divided by delta. Or we can write dy equals to in denominator minus of this is the denominator, and what will be in the numerator? Minus L into dg. So minus minus will be dismissed, and if we divide both sides by both numerator and denominator both by L, what will get? Dy equals to dg 1 minus b plus hk divided by L. So finally, if we do the cross multiplication, we will get the value of the multiplier. So the value of the multiplier is dy dg 1 minus b plus h into k divided by L. So see here, one interesting fact will come that if you compare it with the simple Keynesian model, what is the value of multiplier? One minus b. So this is the value of the multiplier in simple Keynesian model. But here, what do you see? The value of the public expenditure multiplier in simple Keynesian model is greater than the value of the multiplier in ISLM model. So in ISLM model, something is there that weakens the effect of fiscal policy. And what is that? This is the weakening effect. Why does it? Why is it happening? Because in simple Keynesian model, we consider only the commodity market. We are not considering the money market or asset market. So that's why we cannot consider of any kind of change of a private rate of interest, or that's why there is no crowding out in the case of simple Keynesian model. But ISLM model, whenever we are thinking about the interaction between commodity and money markets, so definitely there will be the existence of crowding out. And actually, this indicates the crowding out effect in ISLM model. So this is the value of the public expenditure multiplier in ISLM model. So we can also derive the value of tax multiplier. So here we'll use two types of taxes. First is the lump sum tax and second is the proportional tax. So let's start with the lump sum tax. We'll start from the same type of equation in the commodity market. Y equals to so what is the difference? Difference is there. We'll consider a decline in the volume of tax, whereas the public expenditure remains unchanged. So now what we will see? Y, T and R will be variable here. So we can write it here dy B dy minus B dt minus H dr, and it will be 0. So we can write here dy into 1 minus B plus H dr equals to minus B dt. So this is our now equation. We can write 1C. And money market, from the money market we get the same equation, that K dy minus L dr equals to 0. So this is again 2A. So if we again use the matrix multiplication form, we'll get the left hand side will not change. Look, the same will be same as the previous equation. So it will be 1 minus B K minus L, and sorry, this will be H and minus L dy dr. So we got this coefficient matrix in the case of public expenditure multiplier. So its value is, already we have proved that its value is non-zero. So we'll straight come to the value of the multiplier by Cramer's rule. So what will we get here? Dy equals to minus B dt this is 0 minus B dt 0 H minus L. So we get into 1 divided by delta. So dy equals to, we can write here minus L into 1 minus B plus H into K. and numerator it will be minus minus plus L into B into dt. So if we do it, dy dt equals to, if we divide both sides by L, so we'll get minus of B 1 minus B plus. So this is the value of tax multiplier whenever we are considering the case of a lump sum tax. And as the tax rises, the aggregate demand will decline. So it is there is an inverse relationship between tax and the aggregate demand. So that's why we get a negative value here. And if we check the tax multiplier in simple Keynesian model, so it will be same. We write that dy dt minus b divided by 1 minus b. So here one addition is in the denominator. That means some dampening effect. What is that? That is simply the crowding out effect. So this is the case of the tax multiplier whenever we are considering a lump sum tax. And third case will show the case of a proportional tax. So if we consider, now we'll slightly change the consumption function a plus b into y minus dy. The small t is the tax rate, the value of which will strictly lie in between 0 and 1. That is, it is closer to 0 instead of 1. Plus I bar minus hr plus g. So here what will change? T will change and y will change. So if we differentiate, we'll get dy b dy minus bt dy minus dy dt. My h into dr. In this case, the value of coefficient matrix will change. So dy, we can write here whenever we take it to the left hand side, we can write dy minus b dy plus bt dy plus h dr equals to minus dy dt. So if we take dy as common, we can get 1 minus b into 1 minus t plus h dr equals to minus by dt. And money market from money market equilibrium, the same equation will come. K dy minus L dr equals to 0. So if we again convert it into a matrix multiplication form, our matrix will be, the coefficient matrix will be given as 1 minus b into 1 minus t, k, h and minus l. dy dr equals to minus by dt divided by 0. So again we have to check whether we can apply the Cramer's rule here or not. So what will be the value of delta? Minus L into 1 minus b into 1 minus t plus hk. Sorry, I have made a mistake here. L into Yes, this is the equation now. So what will be the value of dy? We have to use the same process, 1 divided by delta into minus by. This is the value of dy whenever we solve the equation by using Cramer's rule. So finally, what will be the value of dy? Denominator minus of L into 1 minus b into 1 minus t plus hk, and numerator L into b into y dt. So we can write, if we divide both sides by L, numerator and denominator by L, and to the cross multiplication here, we can write dy dt, proportional tax multiplier. It will be definitely negative, and we'll get by 1 minus b into 1 minus t plus hk by L. So see here, whether it is a case of government increases the tax, government reduces the tax, or government increases the public expenditure, in all the cases there will be the existence of crowding out effect. Okay, so here what we see, and the crowding out effect, the value of crowding out effect depends upon three things. H, the interest sensitivity of private investment. K, the K is the coefficient, that means in classical theory we get it 1 divided by the velocity of money. And finally, LL stands for the interest sensitivity of demand for money. So what we see here, if we look at the equation and think intuitively, that if H rises, the crowding out effect will increase. Okay. If L rises, the crowding out effect will decline. So we can say that the value of the crowding out effect, actually, the volume of the crowding out effect is directly related to the interest sensitivity of private investment and inversely related to the interest sensitivity of demand for money. So we can prove it in the near other videos, we can prove it with the help of the diagrammatic explanation, that the case of high interest sensitivity of private investment, the fiscal policy will be less effective because of more crowding out effect. And in case of high interest sensitivity of demand for money, fiscal policy will be more effective because of less crowding out effect. Okay, so we end here. So what we see here, that whenever the government adopts any expansionary fiscal policy, its effect is dampened by the crowding out effect, and the value of crowding out effect will depend upon two most important factors that influence the crowding out effect are: number one is interest sensitivity of private investment, and number two, interest sensitivity of demand for money. So later on we will show that in which situations the fiscal policy will be more effective, and under which situations fiscal policy will be less effective. So we end here, and thank you for watching the video. Goodbye.